Hello and welcome back. So far we have understood central tendency and some measures like range, mid-range and interquartile range. Let us try to understand or see whether central tendency can explain everything or not. So I have taken two data sets here, quiz 1 and quiz 2. 20 students actually participated in two quizzes, quiz 1 and quiz 2. They have got some scores like 5, 6, 9, like that. For out of 10 they have got scores in both the quizzes. So I wanted to understand the behavior of the students in the quizzes, or the conduct the whoever the organizer of the quiz actually need to report to the higher management with one or two numbers or with some statistics. He or she need to explain the behavior of students in quizzes. So let us see whether central tendency can explain that or not. When I took the mean of the first quiz course and the second quiz course, I've got 7. It looks like on an average the students are getting 7. But can I explain that in both quizzes, can I say that in both quizzes students are performing the same way? I think no, because if you look at the graphical representation, there is difference in patterns. So there are 6 people who have got 6 score in the first quiz, and in the second quiz there are 4 people who have got 5 score, and 10 score also was got by some people in quiz 2. But in the quiz 1 there is no person who has got 10 score. So there is a difference in the behaviors or the scores the students have achieved. But the central tendency is giving you one number which cannot explain the behavior of the data. So to explain the behavior of the data, the central tendency one number is not enough. So we may have to take help from variance also. Variance is nothing but how exactly data is spread, right? When you talk about spread, you may have to have a central place, a landmark. Generally, we take the mean as the landmark and try to see how the data is spread from mean. So let us try to understand variance and more about the spread of the data, and try to explain the quiz 1 and quiz 2's data with mean and spread, two numbers, and see how we can efficiently explain the pattern numerically. So let us see what is variance. So variance is the average squared distance of the scores from the mean. The average squared distances. When I say distance, the difference between the mean and all the data points we have to take, those are the distances. If the mean is 7 and there is 5 score, the distance is 2. If the mean is 9, the mean is 7 and the score is 9, the distance is minus 2, like that. So the difference I can say as distance also. So the average squared distance means you need to subtract each number, each data point from mean and square it, sum it and take an average. Here what are we trying to do? We are trying to take squared distances average, summed squared distances average as variance. That means on an average, if you take one data point, it is that far, maybe that far squared far from the mean, you can say that, right? So average squared distance of scores from mean is variance. Why are we squaring? Suppose that there are 2 students who have got 5 score and there are 2 students who have got 9 score. If you don't square and try to take the distances and sum it, these plus 2's and these minus 2's will get cancelled. How did I got 2's there? 5 minus 7 is minus 2 and 9 minus 7 is plus 2. There are 2 students who have got 5's, there are 2 students who have got 9's. So if you try to take the distances and sum, the minus 2's and plus 2's will get cancelled. Let me try to show this. Suppose that there are 2 students who have got 5 score and there are 2 students who have got 9 score. and mean is 7. Suppose that mean is 7. There are some data points in between. Suppose that, right? If you don't square and sum, what happens? 5 minus 7 plus 5 minus 7 and some data points 9 minus 7 plus 9 minus 7. So what is this? This is minus 2 plus minus 2, maybe minus 2 plus and so on, plus 2 plus 2. These 2's get cancelled. So even though there is distance, we are actually nullifying by not squaring the number, not squaring the distances. When you square the distances, what happens? This will become 4, this will become 4, this will become 4, and this will become 4. So the magnitude, the distance is captured there. So we are taking the square distances and then taking the average. So the square distances and average is 1.5. So that is variance. On the first quiz, the variance is 1.5, and on the second quiz, the variance is 3.9. What is this number? If we go back to the data set, if you look at this data, the maximum number on the first quiz is 9. The minimum number on the first quiz is 5. When you calculated variance, you have got a small number 1.5. Right? That means the spread is less. Right? That means the data is close to mean. You are actually taking the squared average distance, and that number actually came 1.5. And on the second quiz, it is 3.9. Let us look at the second quiz data. If you look at the second quiz data, the minimum number is 4 and the maximum number is 10. The mean is 7. The variance is 3.9. That means the magnitude is more. The average square distance is one number, which is a big number when compared to the quiz 1. That means on the second quiz, the students are performing a little farther from the mean. That means on the first quiz, the data is close to 7, and on the second quiz, data is a little far from 7, or the spread is more. That means maybe the students are performing very low or very high on the second quiz. On the first quiz, the students are performing kind of close to when compared to second quiz. So with these two numbers, mean and variance, we can explain the data behavior properly. So if I say on the first quiz, the mean is 7 and the variance is 1.5, and the second quiz, the mean is 7 and the variance is 3.9, that explains that on the first quiz, the students are performing close to 7 marks, and on the second quiz, students are performing a little, more or less from 7. That means the students are, on the second quiz, the students are performing 2 better or 2 worse. So there are students who are performing 2 worse, and there are students who are performing the 2 best on the quiz 2. So with 2 numbers you can explain the mean, central tendency, and the variance. We can explain the data's behavior a little more efficiently. So when you are using a population's data, we always use sigma square to refer to variance and mu to represent the mean. But if the data set is a sample, then the mean is represented with capital M, the variance is represented with S square. And the formula also differs, divided by n minus 1 instead of n. Because it's a sample, we will actually try to divide with a small number. Try to create some benefit of doubt. The variance we create a little more by dividing with a small number. So that is about variance, and with only central tendency we may not be able to explain everything. In combination with variance we can explain a little better. But there is a disadvantage with variance. When you look at the variance formula, it is actually difference squared mean. That means if the data is in centimeters, the 1.5 is a centimeter square, right? So you cannot actually say that on an average a data point is this far. If you pick a data point randomly, you cannot say that on an average that data point will be 1.5 far from 7, because it's the squared units of your data. To bring down the variance units to your data set units, you have to apply square root. That is called a standard deviation. When I calculate the standard deviation, I can say if I pick one data point from quiz 1, if I pick one student's score from quiz 1, I can say that may be 1.224 points far from the mean. That means if you know the mean and standard deviation, you can say any given student score will be between 7 minus 1.22 or 7 plus 1.22, approximately speaking. These are all approximations. Statistics is all about approximations. So let me try to explain this by writing. So if you when I applied square root, what happened? The units came down to the units of your data. Now this standard deviation is eligible to subtract from mean. Why are we subtracting from mean? If you pick a random data point, or if you pick a random student from your data set, that student's score may be in this range, 7 minus 1.224 and 7 plus 1.224. Why? Because this is the average distance of data points from mean. Average distance from data points from mean means if you randomly pick a data point, that may be this far, right? So it is going to be 6, 7, 7, 5.776 and 8.224 on an average, right? If you pick a random data point from quiz 1, the data points or the student's marks will be between 5.776 and 8.224. So with the mean and standard deviation, we can understand data's behavior, as well as we can approximately measure or assess the data spread also. This is called as one standard deviation away, because we are taking the mean and subtracting one standard deviation and adding one standard deviation. Generally, if data is normally distributed, 68% of the data is going to be within this range. We'll talk about that more in coming classes.